Hello, in this video you will learn about 3D view and projection. 3D view is complex as compared to 2D view. Why? Because in 3D we have 3D objects and two-dimensional devices. That is, the graphic devices we are using here for the display of the 3D objects is two-dimensional. So problem is here we have 3D objects and 2D display device. So next question is how we can display 3D objects on two-dimensional devices. So for this, what we can do, we can convert word coordinates into the screen coordinates. So how we can convert word coordinates into screen coordinates? Using projection. So we are using here projection to transform the points in the word coordinate systems into the screen coordinate. That is, we can project 3D object on 2D screen. What is projection? Nothing but just the shadow of the object. For example, you can see here we have 2D object, and after projection you can see it looks like 3D object. That we did in engineering drawing ED. Next is different categories of projection, that is parallel projection and the perspective projection. In parallel projection we have center of projection at infinity, and in perspective projection center of projection is at finite distance. In parallel projection, projectors are parallel to each other, and here projectors are not parallel to each other. And the example of parallel projection is orthographic, isometric, diametric and trimetric. And here we have single point, 2 point, 3 point projection. In this video we will see parallel projection. So for parallel projection you can see this is the example of parallel projection. Here you can see the lines are parallel to each other, so the projector are parallel to each other, and we have center of projection is at infinity, and this is the view plane, and here we have the coordinate position. Next is perspective projection. So you can see here we have center of projection, this is the center of projection, and this is at finite distance, and you can see here these lines are not parallel to each other. So in case of perspective projection, lines are not parallel. Plus you can see here this is the view plane, and we have the coordinate position. Next you can see example of parallel projection. Here you can see we can form parallel projection by extending parallel lines from each vertex of the object. So how we can form parallel projection? For that we can extend the lines from the each vertex of the object. For example, we have this object on the plane. So how we can perform projection right now for this? As you know, we were doing in rotation. When we will rotate the object about x-axis, then x coordinate remains unchanged, and we will perform rotation on the yz plane. So in this case you can see here we will do nothing on the x coordinate. You can see lines are projected, and you can form this parallel projection on for this object like this. Same we did in engineering drawing. We did number of experiments like this for different objects. Next is orthographic projection. This is also a part of parallel projection. That is the part of parallel projection. Here projection is perpendicular to the plane, and the center of projection lie at the infinity. Lines, you can see the line length is not changed in this projection, and this is used in engineering drawing. And you can see here this is projection on the one of the coordinate planes where we have x0, y is 0 or z is 0. Same as we did in the rotation. When we will rotate the object along x-axis, then x coordinate remains unchanged. You can see here matrix for projection. When x is 0, this coordinate is 0. When we will perform projection on y coordinates, you can see here y coordinate is 0. When we will perform projection on the z coordinate, then this remains 0. Next we have a question for you, that is find orthographic projection for a unit cube onto the x is 0, y is 0 and z is 0. So you can see here we have different points, and you will find out the orthographic projection for this unit cube for x at 0, y at 0, and z at 0. For this you will construct a matrix for the homogeneous coordinates, and after that you will use these matrices and you will find out the orthographic projection. So that's all about this video. If you have any question, you can comment below, and thanks for watching this video.